Alright, so here we are with Chapter 9, Section 4, Operations with Functions. What we want to be able to do here is we want to add, subtract, multiply, and divide functions. That should all be pretty easy and hopefully not that bad. And the main thing you want to be able to do is write and evaluate composite functions. That's going to be very important, especially for those of you that are taking pre-cal. That's something you cover in pre-cal second 6 weeks, I believe. So you need to make sure you understand that. Alright, so let's look at what we're talking about here. Let's do some notation. Okay, so you can see here for addition, if I say parentheses f plus g of x, I mean f of x plus g of x, which means take one function, add it to the other. Just combine like terms. Subtraction, same thing, but subtracting like terms. Multiplication, you've done that. You've done that with polynomials, so that shouldn't be that hard. It's just like distributive property or vertical multiplication or something like that. Division, we want to factor. Yes, factoring is back. And you want to be able to cross out, say, like terms. So let's look at some examples. And let's start off with saying f of x is 2x squared plus 4x minus 6, and g of x is equal to 2x minus 2. Actually, we're going to use that for all of our examples. Okay, and so let's do the addition f plus g of x, which means I'm going to add f of x plus g of x, which means I'm going to say 2x squared plus 4x minus 6, and I'm going to add to that the 2x minus 2. Now you can write that under it, next to it, whatever. But the main idea is you're going to combine like terms, and I'm combining the 4x and the 2x and the negative 6 and the negative 2. 4 plus 2x is 6x. Negative 6 minus 2 is negative 8. And that's what f plus g of x is. Now the minus, same thing, but this time I'm going to subtract the like terms. So here's where you have to be careful with that. And notice how I will write that. I'm going to say 2x squared plus 4x minus 6 minus, in parentheses, 2x minus 2. What is that minus going to do? It's going to change the signs of each one inside the parentheses. So that becomes minus 2x plus 2. So now I'm saying 2x squared plus 4x minus 6 minus 2x plus 2. Combine your like terms. 4 minus 2 is 2x, and negative 6 plus 2 is negative 4. So those are my two answers from adding and subtracting. Again, this should be stuff that's fairly easy. Just combining like terms shouldn't be that hard. Multiplication. Now we're going to do like the g of x times f of x. And again, here you're just multiplying distributive property, vertical multiplication, however you want to do it. You know me, I like to do vertical multiplication, so that's what I'm going to do. So I'm going to multiply here. Negative 2 times negative 6 is positive 12. Negative 2 times 4 is negative 8. Negative 2 times 2x squared becomes negative 4x squared. Then I'm going to move down to the next row, and I'm going to say 2x times negative 6 is negative 12x. 2x times 4x is 8x squared. And then 2x times 2x squared is 4x cubed. Notice how it's all lined up to add your like terms. So you do that, and then you are done. Okay, so now let's look at division. I'm going to do that on another slide. So with division, we want to make sure that we are dividing correctly. So we want to set it up correctly. The first thing with division is to factor. So factor it out completely. 2x squared plus 4x minus 6. Then you have your 2x minus 2. Now, if you notice here, all the numbers are on top are divisible by 2. So I'm going to head and factor out a 2 first. We're left with x squared plus 2x minus 3. And then on the bottom, both of those numbers are divisible by 2. So I'm going to factor out a 2 there also. So 2, and I'll be left with an x minus 1. Now the x squared plus 2x minus 3, plus and minus means I can make parentheses of a plus and minus. Two numbers that multiply to give me a 3 and subtract to give me a 2 are 3 and 1. And 3 minus 1 is positive 2. Okay. At that point, you have now factored it out, and now you divide. And now you can see what crosses out, leaving you just with x plus 3. So f divided by g is x plus 3. Okay. those are things that if you practice with them, they become easier. So you need to make sure you kind of walk through those examples, practice some of the things that you've learned before, like in multiplying and factoring and things like that. So now we're getting to the composition of functions. And this becomes important. Now, the first part of this is dealing with the trying to get into the proper notation, but at the same time realizing how it reads. Now, F, that's an F circle G, not fog, F circle G of X. And what that means is F of G of X. And what that does is that you're basically taking the G of X function and you're working it into the F of X function. So you work outward. So you start with the G, put, like if you're doing this with like a number, you're going to put a number into the G of X function. Whatever answer you get, you will put that answer into the X for the F of X function. Okay? So you'll see an example of that. Okay, so here, f of x is going to be 3x plus 1, and g of x is going to be x cubed. Okay, and let's start off with just doing numbers. So let's say find f of g of 2. Okay, so what that means is I'm going to put the 2 in place of the x on the g function first. Okay, so 2 cubed is 8. Now I'm going to take that answer, and I'm going to put that answer into the x function of the x of the f function. So I'm going to say 3 times 8 plus 1. 3 times 8 is 24, plus 1 is 25. Okay, so it's key to note which order they're in. So you go and you work your way outward. The first number, the number that they give you will go into the function or the x of the function that it's next to. Then that answer will go into the next one. Say, for example, g of f of 2 means I'm going to put 2 in place of the x for the f function and say 3 times 2 plus 1, which is 7. Then I'm going to put that into the g function, so put 7 into there and say 7 cubed, which is 343. Notice how they give you different answers, so order is important. Keep that in mind. Okay, so another example. Okay, here I have f of x is equal to 2x minus 3 and g of x equal to the square root of x plus 3. And then I'm going to say find f of g of 9. Okay, well the square root of 9 is 3 and 3 plus 3 is 6. Then I'm going to put the 6 in place of the x on the f function, which would be 2 times 6, which is 12, minus 3 is 9. Weirdly coincidentally, brought us back to the original number. That was just oops. So go with that. Just kind of worked out that way. The next one, let's try this. Put the f, 26 in place of the x for the f. So that would give me 2 times 26, which is 52. Minus 3 is 49. And then I'm going to put 49 into the g of x. So the square root of 49 is 7. Plus 3 is 10. So you can see here, this shouldn't be all that difficult. It's just a matter of plugging them in the right way, doing some simple mathematics and calculations, and you should have it. The more interesting one, the one you're more likely to see in pre-cal, is the writing of compositions or composite functions. And this basically means you put one function completely into the x of the other function. Okay, that's our key. So we want to make sure that we're substituting a function into the x of the other. So for example, if it says f g of x, you're going to put the g function in place of the x for the f function and then simplify. If it says gf of x, you would go the other way around. Okay, so make sure you've copied this. If you have to, pause it because I'm just moving on. So here's my last example, or one of my last examples, and we're saying f of x is equal to 5x plus 2 and g of x is equal to 2 divided by x minus 1. And to say f g of x means I'm going to put that 2 divided by x minus 1 completely in place of the x of the f function. So that would look like 5 parentheses 2 over x minus 1 plus 2. Distribute the 5. Okay, so skipped a little bit here by accident. So distributing the 5, all you can do is say 5 times 2. So that's really all you do here is just say 5 times 2. That's 10. 10 over x minus 1 plus 2. That's all I can do. There's nothing else I can do. So that's that. So f g of x is 10 over x minus 1 plus 2. The composite of f of g. G f of x. Now notice that I could also be writing these with circles and say like g circle f of x, but I usually prefer this notation more. Kind of let you know which way you go. But in pre-cal, you probably will see this, so keep that in mind. That's how sometimes they like to write it in pre-cal. So here I'm going to put the f of x function in place of the g of x. So I'm going to put 5x plus 2 in place of the x on the g function, which means I'm going to say 2 over, and instead of an x, I'm going to say 5x plus 2 minus 1. Okay, well, I don't need to distribute anything, so I drop the parentheses. I'm going to say 2 over 5x, and combine my like terms. 2 plus 1, or 2 minus 1 actually, becomes positive 1, and you're done. That's it. Practice with those. It's not hard to know that first step, but got to remember that you got to simplify a little bit. Again, if you do have any questions, send it to me through Edmodo. I will be checking those. Hopefully you will get these notes. They are up, so make sure you get them. Thank you.